Imagine you are sitting on a small fishing boat, 30 miles off the coast of Sumatra. The sun is warm, the air is still, and the ocean beneath you is a deep, tranquil sapphire. You feel a gentle swell lift your hull, a slow, rhythmic rise of perhaps 2 feet, and then, just as softly, the water settles. You wouldn't even call it a wave. You might not even look up from your nets. But in that fleeting moment of calm, a force equivalent to 23,000 Hiroshima-sized atomic bombs has just passed silently beneath your feet. That gentle rise was the crest of a monster traveling at 500 miles per hour. While you bobbed peacefully in the open sea, that invisible energy was racing toward the horizon, carrying the weight of the entire Indian Ocean behind it. This is the great paradox of the tsunami. It is a ghost in the deep and a god at the shore. To understand how something so massive can remain so hidden, we have to look past the surface of the water and into the very machinery of our planet. Most of us grew up thinking of waves as things driven by the wind. We watched them curl and break at the beach, white foam dancing on the crest. But those waves are skin deep. A wind-driven wave is a surface phenomenon, a mere ruffling of the ocean's hair. Even in the most violent hurricane, the chaos rarely reaches deeper than a few hundred feet. Below that, the abyss remains silent and still. A tsunami, however, is not a wave of the surface. It is a wave of the entire water column. To visualize this, imagine the ocean as a massive, heavy carpet. A wind wave is like a small ripple you flicked into the fabric. It moves quickly across the top, but the weight of the carpet stays put. A tsunami is what happens when someone grabs the entire floor beneath the carpet and jerks it forward. The movement doesn't just affect the top layer, it displaces every single drop of water from the sunlit surface down to the crushing darkness of the seafloor, 4 miles below. This displacement usually begins with a violent rupture. The Earth's crust is not a solid shell, but a jigsaw puzzle of tectonic plates constantly grinding against one another. In places like the Ring of Fire, one plate is often forced beneath another in a process called subduction. These plates get stuck. They snag. For centuries, they build up an unimaginable amount of elastic tension, bending and warping like a wooden ruler being pushed to its breaking point. Then, in a fraction of a second, the snag snaps. The overriding plate springs upward like a released bowstring. When hundreds of miles of seafloor suddenly thrust upward by 30 or 40 feet, they don't just move rocks. They punch the entire ocean upward. This vertical shove creates a massive mound of water on the surface, a bulge that gravity immediately tries to flatten. As that mound collapses back down, it pushes the water outward in every direction, birthing the invisible wave. In the deep ocean, the physics of this wave are counterintuitive. Because the water is so deep, the wave has an incredible amount of room to spread its energy. Its wavelength, the distance from one crest to the next, can be over 100 miles long. Because the wave is so wide and the ocean is so deep, the actual height of the wave on the surface might only be a foot or two. This is why pilots flying over the Pacific or sailors in deep water never see them. The energy isn't tall, it's wide and deep. The speed of a tsunami is dictated entirely by the depth of the water. In the deep trenches of the abyss, these waves travel at the speed of a commercial jetliner. If an earthquake occurs off the coast of Chile, the resulting tsunami can cross the entire Pacific Ocean and hit Japan in less than 21 hours. It is a relentless, high-speed pulse of kinetic energy, moving through the water with almost no friction to slow it down. But the true horror begins as the wave approaches the shore and the ocean floor begins to rise. This is a process scientists call shoaling. As the water gets shallower, there is no longer enough room for all that energy to hide beneath the surface. The front of the wave begins to feel the friction of the seabed, causing it to slow down. But the back of the wave, still in deeper water, is still racing forward at hundreds of miles per hour. Think of it like a massive pileup on a highway. The front car slams on the brakes, but the thousands of cars behind it keep slamming into the back. The wave begins to compress. The horizontal energy is forced to become vertical. The long, low, invisible swell begins to grow, thickening into a massive, moving wall of water. It doesn't curl and break like a surfer's wave. It looks more like a rising tide that simply refuses to stop.
There is a chilling precursor that often occurs just before the water hits, the drawdown. If the trough of the tsunami reaches the shore before the crest, the ocean appears to vanish. The water is sucked away from the beach, retreating hundreds of yards and exposing shipwrecks, coral reefs, and flopping fish that haven't seen the sun in decades. To the uninformed, it looks like a miracle or a curiosity. To the geologist, it is the earth drawing in a deep breath before a scream. When the wave finally arrives, it isn't the height that kills, it's the mass. A typical breaking wave at the beach might have a few feet of water behind it before it dissipates. A tsunami has miles of water behind it. It isn't a wall you can dive through, it is a relentless conveyor belt of liquid lead. 1 cubic yard of water weighs nearly a ton. Now imagine millions of those tons moving at 30 miles per hour, filled with the debris of everything the wave has already destroyed: cars, trees, houses, and shattered concrete. For a long time, we thought we understood the limits of these events. We thought tsunamis were the exclusive domain of massive, megathrust earthquakes. But in recent years, we've discovered something far more unsettling: the silent tsunami. In 1998, a relatively modest earthquake hit Papua New Guinea. It wasn't the kind of tremor that usually triggers a massive wave. Yet, minutes later, a 45-foot wall of water annihilated the coastline. The discovery changed everything. Scientists realized that the earthquake hadn't caused the tsunami directly. Instead, the shaking had triggered a massive underwater landslide. An entire section of the continental shelf had slumped into the deep trench, acting like a giant piston that displaced the water. These landslide tsunamis are terrifying because they provide almost no seismic warning. They are local, sudden, and incredibly violent. Even more surprising is the discovery of meteotsunamis. These aren't caused by the Earth moving at all, but by the atmosphere. Rapid changes in air pressure, often during intense storms, can create a wave that resonates with the speed of the water, building up energy until it hits the coast with the same force as a tectonically triggered wave. It reminds us that the ocean is a sensitive instrument, capable of reacting to the slightest nudge from the world above or below. Today, we have a thin line of defense. A network of deep ocean sensors known as dart buoys sits on the seafloor, measuring the pressure of the water column above them. They can detect a change in water height as small as a fraction of an inch in 4 miles of water. When they sense that invisible pulse, they beam a signal to a satellite, which alerts warning centers around the world. We are finally learning to hear the ghost before it reaches the shore. But technology has its limits. The physics of a tsunami are so grand and the energy so absolute that no sea wall or early warning system can truly tame them. We live on a planet where the very ground beneath our feet is a shifting, living thing. We reside on the thin crust of a cooling cinder, surrounded by an ocean that holds 97% of our planet's water. When we look out at the horizon, we see a flat, blue line. It looks eternal and unchanging. But beneath that surface, there is a mechanical heartbeat. There are gears turning in the dark, pressures building in the silence, and invisible waves that can cross half the world before they are ever seen. The tsunami is a reminder that we are guests on this planet, and that the ocean, in all its beauty, is a machine of unimaginable power. The next time you stand on a beach and feel the sand pulling away from your toes as a small wave retreats, remember that the ocean is always moving. Most of the time, that movement is gentle. But somewhere, deep in the trenches where the light never reaches, the earth is bending. The carpet is being pulled. And out there, in the vast, open blue, the invisible wave is already beginning its long, silent journey toward the light.